Here we go. This is section 2.6 in Trig. We are talking about combining functions. So, for instance, here, number one. They're asking for the sum of functions f and g at the point 2. The easiest way to do these is to find f of 2, if my Sparty catches up with me here. Please work today, thank you. Plus g of 2. Okay, that's the easiest way to do these. So look at the graph. What's f of 2 equal? F of 2, you go up, it equals 3. Yeah. So we're going to have 3 plus g of 2. G is the blue line. So if we go over to 2 and up to the blue line here on g, what does that equal? 5. So 3 plus 5 is going to give me 8. That would be my answer for that one. I'm not going to bother putting them in the box. But that's what you need to do for all of these. So like the last one, it would literally be f of 2 divided by g of 2. Okay, that's the best way to do them, and look at the graph. Okay, any questions on that one? Everybody good? All right. Now, the next kind, so suppose the rule of the function of f is add 1. And the rule of the function g is multiply by 3. Well, what they mean is you're coming up with the arithmetic expression, okay? So you have to input a variable. And obviously here on the left-hand side, they have them defined with x's. So if the function of f is add 1, it's going to be x plus 1. If the function of g is multiply by 3, it's going to be 3 times x, okay? And then composition of functions. I wanted to go over that as well. If you remember, f of g, this right here is composition of functions. So this is the same thing as saying f of g of x. Okay? This is the same thing as saying g of f of x. So composition of functions, you are putting in this top one here, you are putting the function g inside the f function. So what this translates to then is f of, if my g function is 3x, so now I'm putting 3x into the f function. Okay, and if my f function is x plus 1, then I'm literally putting 3x plus 1. And that would be my answer. That's all I can do with it, because those aren't like terms. You don't necessarily need the parentheses around the 3x, but I was just kind of putting there to delineate what we put as input. Everybody okay with that one? Okay, so the g of f of x, same kind of deal. Now I am saying that this is g of, my f of x function is the x plus 1. So I'm putting the f of x function into the g function. So the g function is 3 times x, so that is 3 times x plus 1. And quite honestly, I don't know if they'll take it that way or if you need to distribute it out and make it 3x plus 3. I don't know. Play with it. See what they make for you. So you could either write it as fog and golf with the little O, or you can write it this way. Visually, I actually prefer to see it this way because it's a visual thing. I know then that f of x is going into g. But on these, you're kind of working right to left. Because if you say you're working inner to outer, the inner is the rightmost part, the part closest to the x. Does that make sense? Everybody okay? All right. So let me erase that and move on. Always forget. So these, when you're combining functions by adding, subtracting, multiplying, dividing, and you have to find the domain. The trick to these, again, is the domain. And really, you need to look for those weird instances where, like, you're going to have an x in the denominator. Well, the denominator can't be 0. So what value of x would make the denominator 0? That has to be excluded from the domain. Same thing if you have a square root. We can't take the square root of a negative number. So we have to look at the values of x that would make the square root give us a negative, and those are the things we need to avoid in the domain. But for the most part, they're straightforward. You're just literally adding the functions together or subtracting the functions. So for instance, on this one, find f plus g. You are literally taking x squared plus 7x plus 3x squared minus 1. Okay, well, combine like terms. This is easy enough. So you're going to have 4x squared plus 7x minus 1. That is your f plus g of x function. Not a big deal. Now, the domain of f plus g. Again, when I think domain, I look for what needs to be restricted. I don't have any x's in the denominator. I don't have any x's under radicals. It's free. So it is negative infinity to positive infinity. No big deal there. Now, I will point out on the f minus g, you got to be careful with the negative. I'm just going to set this one up, and then I'll let you all finish it. But on the minus, remember, this is going to be x squared plus 7x minus the entire g function, which is 3x squared minus 1. So do not forget to distribute the negative. Then combine like terms. Okay? I won't finish it, but does that make sense? Everybody okay? All right. Okay, let me keep going because I do want to talk about the f divided by g. So f divided by g, now I've scrolled down to where I don't know what f is. X squared plus 7x over, what's my g again? 3x squared minus 1. Okay, now, believe it or not, I think, I want to say delta math, I think WebAssign lets you just leave it that way. Okay, so yay, which there's really not that much to do to it. But the domain, that's where the rub comes in. Numerators can be 0, so nothing weird there. Denominators cannot be 0. So what we first need to do here is to solve, set our denominator, the 3x squared minus 1 equal to 0, and solve for the value of x that's going to make it equal that. So 3x squared equals 1, x squared equals 1/3. Okay, so then how do I solve for that? Square root. So I'm running out of room, but if I scroll up, I'm going to have, yeah, that's all right. So x is going to equal plus or minus. Don't forget, when we solve a perfect square, the square root procedure says you have to take plus or minus that. Okay, so plus or minus the square root of 1/3. Well, that is plus or minus 1 over root 3. Now, quite honestly, that is not rationalized. Square root of 1 is 1. That's why it was taken off the 1. We need to rationalize this, I'm guessing. So remember, to rationalize means to get all the ugly crap off the bottom, like roots or i's or any of that stuff. Okay, so if I rationalize this, then that's going to give me plus or minus root 3 over 3. So that is what we have to avoid. Okay, we have to avoid this point in our denominator. So we have to avoid that in the domain. Okay, so our domain then, I'm going to just write it above here. Our domain is going to be from negative infinity up to negative root 3 over 3 union negative root 3 over 3 to positive root 3 over 3. Sorry, I'm running out of room. Union root 3 over 3 to infinity. Okay, so you're gonna, if there's 2 values that you have to avoid, your domain is going to be split up into 3 parts because you have to avoid both of those values. And that's why these are rounded parentheses instead of square brackets. Okay, because it cannot equal positive root 3 over 3 or negative root 3 over 3. Any questions there? Feel free to ask questions. I'm sure Jake would appreciate it as well. I'll repeat them if somebody has them so you can hear. Yeah, if Kate asked if we had to have the union in there, WebAssign will take union or comma. Yeah, so if you don't want to bother with the union, quite honestly, I'm lazy and I never want to bother with the union because it means going over to the symbols on the right. I just put comma and that's fine. Everybody okay with that? All right, let me erase and keep rolling. The worst thing about Smart Ink is you've got to erase each screen. It doesn't roll with you. Okay, this one's same kind of deal. Now, I'm not going to do it for you, but I'm going to talk a little bit about domains. Let's just talk about the possible domains of f of x and g of x the way they are. Okay, so f of x, the domain of f of x here, what is true about a square root function? What can I not have in a square root function? Maybe I should say that. A negative. Okay, because if we're talking functions, we're talking about polynomials that we need to be able to graph, and so they have to stay real. Okay, because remember, if we take square root of a negative, we get ugly eye, and that's not what we want. So if I'm trying to find the domain of just f of x, that means that 36 minus x squared has to stay greater than or equal to 0. Now, we can get square root of 0. That's fine. But 36 minus x squared has to stay greater than or equal to 0. So then it's just a matter of solving it. So negative x squared is greater than or equal to negative 36. I just subtracted 36 and move it over. How do I get rid of the negative? Yeah, I'm going to have to divide by -1, which means my sign is going to flip, right? Okay, remember when you divide by a negative, you change your arrow. Now, this is kind of, anytime you have a quadratic inequality, you solve for critical values, and then you have to test the intervals on the number line. I don't know if you all remember that. One of the reasons I wanted to go over this. So the critical values here, so critical values that come out of this is if I set x squared equal to 36, x would equal positive or negative 6. Would you all agree to that? So what that does for me then is if I have a number line, if this is -6 and this is +6, I have to test all these intervals. So this interval would be from -infinity up to -6. Now, my domain started off with the 36 minus x squared is greater than or equal to 0. So what symbol would I need on the -6? A square bracket or a round parenthesis? Square bracket, because it can equal 0. Sorry, now I copied over the negative. It can equal 0, so I can have square brackets on these. So then this interval is -6 to +6. This interval is +6 to infinity. Okay? I have to test a number in each of those intervals. Okay? So over here, I'm going to let x equal -7. Never test an endpoint. Okay? You always want something inside the interval. So if I plug in a -7, does that work? Does 36 minus -7 squared, is that greater than or equal to 0? Well, -7 squared is going to give me 49. Is that doable? No, because that's going to give me a negative. Okay, so this is a big fat no. Same thing over here. This is going to be a big fat no as well, because if I put in a +7, I'm still going to get 36 minus 49, right? In the middle, if I test x equals 0, well, then I'm going to get 36 minus 0. Is that greater than or equal to 0? Of course, that's a yes. So this right here would be my interval for my domain. So my domain of f of x is literally -6 to 6. That's my domain. Okay, that's it. Now, you can do the same process with g of x. That's even easier because it's not a quadratic. You don't have to test the intervals. You just solve it. Okay, but the one thing I will tell you is when you get down to the bottom here, where you've got f over g, where g is in the denominator, okay, it also can't be 0. So then you may have to change a square bracket to a rounded parenthesis. Are you all understanding what I'm saying? Okay, so if we find the domain of g of x, it can include 0, right? Like the value that's under the radical can be a 0, but it can't be when it's in the denominator. So you're going to have to be careful of your square brackets or rounded parentheses on your domain, okay? And on this one, you're still going to have to be aware of the domain of your f's because you can't have square roots of negatives. So in this particular case, since both functions have a root on them, you're going to have to be especially careful of domain values, okay? Yes, Kate has a question, Jake, just a minute. Uh-huh. Well, so you need to, so once you find the domain of like f of x and g of x, how does that impact if you add them together? How does it, essentially, yes. It is the, and if you guys look on your Google Classroom class drive, which I know I brought up at the very beginning of the semester, I haven't really brought it up since then because we were all here, but the PowerPoints to all of these sections are in that, and they go over all the rules and whatever, but essentially when you are combining functions together, the domain becomes a combination of the domains of the two functions you're combining. Does that make sense? So you have to be aware of both the domain of f and the domain of g in order for it to work. Okay, so I'm not prepared to bring that up right now, but look in the class drive folder on Google Classroom and the PowerPoint for this section, and they talk more about domains. But that actually is a very good question. Okay, so yeah, the domain of the combination of these functions is affected by each of the domains of f and g. I'm trying to give you enough information without just giving it to you. I do want you to work for it, though. Okay, that's kind of the same thing. Let's look at a couple of these. Okay, so f of 2. There's a couple different schools of thought on how to do these. One way is hard, poke you in the eye and no thank you. The other way is super easy. So by all means, please do the super easy way. They both give the same answer, but I'm all about working smarter and not harder. So again, work inner to outer. I've had some students in years past, they want to do f of f first. Well, you can do that, but again, it's like poke yourself in the eye because it's not necessary. Work inner to outer, and that first evaluate f of 2, okay? So if we plug 2 into the f function, so f of 2 is 2 times 2 minus 4, we get big fat 0, right? Now, so this part yielded the number 0. So now what we're finding is f of 0. So f of 0 then is 2 times 0 minus 4, or negative 4. That would be the overall answer. So again, work inner to outer. Okay, you can find f of f or g of g, but it's not necessary. Just if they actually give you a value of x to plug in, start there by all means. Okay. Same thing here, it's just written differently. Okay, this is the exact same problem. They're just using the fog and Goff notation or whatever versus, you know, f of f or whatever. So this is the same thing as saying f of g of negative 2. first find g of negative 2, okay? Which is, if I plug in negative 2, that's 2 minus negative 2 squared. Again, be careful with parentheses. We're at the stage of the ball game here in math and trig that we should know use parentheses anytime we substitute in a value for a variable. So this is going to be 2 minus 4, or negative 2, right? So this whole thing then, g of negative 2, that whole expression equals negative 2. So now, find f of negative 2. It just so happens that they're all negative 2's, but I'm trying to use different colors so you understand where they're coming from. Does that make sense? Everybody okay with that? All right. Okay, these, I guess I need to erase this. These next couple here, use the given graphs of f and g to evaluate the expression f of g of 2. Do it just like we did the ones above. Start with the g of 2, okay? G, oh gosh, these are kind of hard to read. G is the blue line, okay? So g of 2 equals what? G of 2, if I put in 2, I get out a 5. So now we are evaluating f of 5. So now we go over to 2, 3, 4, 5, over to 5, and up to where it is. What's f of 5? 4. That would be your final answer. Okay? So you're reading the graphs. Start with g of 2, figure out what its output is, and then put the output value into the outer function, the f function, and then figure that out. We okay? Okay, same thing here, but this is g of g. So am I even going to use the f function? No. Okay, I put in g of 1, figure out the output, then put that output back into g again. Again, same thing here with f of g, g of f. Let me do one of those. Just the other ones I did were all kind of easy peasy. So again, just one more example here. This is the same thing as f of g of x, or f of 3x minus 1. Okay, so then every time you see an x in the f function, you're putting in the 3x minus 1. So this is 2 times 3x minus 1 plus 3. And again, don't forget to distribute, all that good jazz. Okay, now the domain, okay, again, you're kind of looking at your end result for the domain. And we don't have any radicals, we don't have any denominators, so domain would just be negative infinity, infinity. Okay. I just wanted to show you another one of those. So, moving right along. Okay, this one, when you do combination of functions, you're going to have to be careful. Well, actually, you're not, because that's a cubed root. Do we have any restrictions on what cubed roots can have under them? No, odd roots, you can take odd roots of negative numbers. The cubed root of negative 8 is negative 2. Okay, because again, think opposite. Negative 2 cubed is negative 8. You can actually do odd numbered roots of negatives. So there really isn't any restrictions on those. This one, you're going to have to be careful when you're finding domains, because there's actually 2 values that need to be excluded. You have to worry about the value that's excluded from the f function and the value that needs to be excluded from the g function. So what value here needs to be excluded from f? 0. What value needs to be excluded from g? Negative 2. Okay, So 0 and -2 are each going to have to be avoided in your domains, okay? Same kind of, now f of g of h, again, just to point out, I love it when the AC is running and the board is shaking. Jake, I don't know if you can see the shaking, but it's driving me nuts. So f of g of h of x, that's the same thing. Okay, so you put h into g, then take that answer and put it into f. I'll get you started here on this last one just by helping you do the very first one. So a spherical balloon is being inflated. The radius of the balloon is increasing at a rate of 9 centimeters per second. Find a function f that models the radius as a function of time t in seconds. Literally, this is just 9t. Okay? If it's inflating 9 centimeters per second, if t is seconds, then in 2 seconds it's going to be 18. In 3 seconds it's going to be 27. So it's literally just 9 times t. Okay? Now, volume, I'm not going to do this one for you, but you may want to look up, if you don't remember the formula for the volume of a sphere. Actually, I would probably have to check myself by looking it on Google as well. I think I know it. Isn't that the fourth? Anyway, I'll make you guys look it up. Okay, but that's where this part B is going to come from. You need to look up the volume of a sphere. And again, it's using radius r, but then they want you to find g of f. So if f is modeling the radius, then they want you to put the 9t into the g function. Okay, pretty straightforward, I think. And that's it. All right. Okay, hope that